following video interview is controversial in nature and does not necessarily reflect the views of the producers nor mainstream academia. The viewer is encouraged to refamiliarize themselves with the standard historical and scientific text before making presumptive conclusions.
I'm not surprised at this recent scandal that they dug up about the dumbness of the school books they're writing. Here's the government telling these outrageous lies to every child in America, every adult in America, and every old person in America. They've been stealing and hiding technology for so long, they don't want it to move any faster.
Welcome to the 33rd Parallel, a video series about science, technology, and the politics that control it. For a long time now, scientists have been busy congratulating each other for proving some aspect of the theory of relativity. As recently as 1995, they've rewarded their colleagues with Nobel Prizes and declared long-held beliefs about the theory as proven fact. Meanwhile, we, as part of the unwashed masses, wait patiently for our eminent scientists to let us in on the joke. Aside from the atomic bomb, just what part of this illustrious concept can we hold in our hands and use in our daily lives? One is left wondering if scientists even care about the day-to-day phenomena that are still left unexplained. We may ask, what is gravity? And the answer is gravitons. Or, what is electricity? Well, it's electrons. Aside from their precious relativity, are there coexistent theories that are worth considering? After all, the majority of our greatest scientists, Michael Faraday, James Clerk Maxwell, Sir William Crookes, and Lord Kelvin, never even heard of relativity, nor would it have helped them if they did. Just what made scientists want to embrace the peculiar claims of a second-rate clerk in a Swiss patent office as the preeminent end-all to scientific progress? As almost an apology to the unworkability of Einstein's rants, we are offered a steady stream of new and ever more complex quantum mechanics and string theory to dazzle us, or baffle us beyond belief. If Michael Faraday and Sir William Crookes never used relativity to further their understanding of gravity and electrodynamics, just what did they base their experiments on? And why do we never re-examine those concepts? Is there a forgotten physics with a different set of rules, hidden away from us early in the last century by a powerful elite who fear that the technology based on it will strip away their power and wealth and liberate us from their grip? A bold and outrageous statement that can never be proven, right? Wrong. William R. Lyne is our guest tonight. He's the author of 3 books. Pentagon Aliens, formerly Space Aliens from the Pentagon, now in its 3rd printing, Occult Ether Physics, and The Free Energy Surprise. Mr. Lyne was born in Big Spring, Texas, and raised in the boom towns of the great West Texas wildcatters. He had the opportunity of being educated about fuel and its impact on industry firsthand. From there, he pursued an interest in aviation in Army Air Force, where he earned a position in Air Force Intelligence. He has acquired a BS degree with a double major in Art and Industrial Technology from Sam Houston State University in Huntsville, Texas in 1969. He also has the distinction of living in New Mexico for the past 25 years. during a time and place where knowledge of saucer technology necessarily meant knowing individuals who worked on top-secret projects at Los Alamos and Alamogordo, where individuals such as Werner von Braun and his Nazi collaborators were well known to the community at large, where, much like those individuals who had the misfortune of living in or near Mena, Arkansas, never got the chance to tell the rest of the world what was really going on. Well, today Mr. Lyne will do just that. Mr. Lyne, welcome to the 33rd Parallel. Okay, I'd like to get into some free energy technology now. The first thing I'm really fascinated about is your discussion of the atomic hydrogen torch. And if anybody's a welder these days, they probably haven't even heard of an atomic hydrogen torch. Maybe you might want to explain a little bit about that and why it's so special.
Interesting thing is, since I came out with this material, just this year, in the immediate future, General Electric is now issuing a new version of an atomic hydrogen torch. Isn't that interesting?
How about that?
And
how did that happen?
A person phoned me the other day and told me all about it. And they have a new atomic hydrogen torch they're preparing to release for the public. And I thought, wow, this is amazing. Isn't that a coincidence that it was dead for all those years?
Yeah.
And now I published something on it, and now they're coming out with it.
Now, I wonder how they're going to explain the inordinate amount of energy. You might want to maybe talk about why this is so special, this torch.
Well, of course, the discovery of the atomic hydrogen, what I call the atomic hydrogen process, was supposedly made by Langmuir about 1909 or 1912. And he was a chemist who had a lot of discoveries in the area of electrolysis and so forth. And he claimed, and of course the thing about Langmuir is he was an early relativist. So
right?
He believed in relativistic, what I call RQMs, relativistic quantum mechanics. And he basically, believed in the idea that however much energy was produced when the hydrogen recombined was the amount of energy it took to separate the hydrogen molecules into from diatomic molecules into monoatomic hydrogen. So basically, this process involves the separation of hydrogen, which tends to come as diatomic molecules, two atoms together, into its separate atoms. And then when those atoms come back together, they release 109 kilocalories per mole.
It sounds like a lot.
Molecules, per mole. And so that is a lot of energy. Now, what I found was a well-known Encyclopedia of Science, which says that it takes 103 calories per gram mole to separate the hydrogen, although the relativistic quantum mechanics say that it takes the same amount of heat to separate the molecules as you get back when they recombine.
So you're getting nothing in
you end up getting it all, that you're just using electrical energy to separate it, and then you get it back when it combines. Well, why even do it? I mean,
right.
If you could just do it with electricity, except you get temperatures that are far above what you would get with an electric arc.
In fact, you discovered an old text on this reaction, and even a photograph of an atomic hydrogen torch. Hydrogen being set free in a chemical reaction is often more reactive than hydrogen gas. The activity of such nascent newborn hydrogen in the act of liberation from its compounds is due to the hydrogen being in the atomic state. And down here, hydrogen molecules dissociate to atoms endothermically at high temperatures. Heat of dissociation about 103 calories gram mole. An electric arc or by irradiation. The hydrogen atoms recombine at the metal surface to provide heat for the acquired welding.
Now, I've been assured that this has to be a typographical error on the part of the Van Nostrand Encyclopedia people, even though this particular paragraph comes out of what is something like the 5th edition. Now,
is that right?
They're
so 5 editions of mistakes.
Yeah, 5 editions. They have just carried this nobody's caught it, you know. And the thing is this company published books on Tesla at one time when Tesla was alive.
Oh, is that right?
Yes, same company.
Well, that's interesting that they would claim that they've made mistakes in 5 editions. Here we have this is circa 1933. It's a welding book, welding and its applications, and it has here atomic hydrogen arc welding. In general, it says here, molecular hydrogen, or hydrogen in its normal state as distinguished from atomic hydrogen, is a diatomic gas. That is, each molecule consists of 2 atoms. When hydrogen is broken down into the atomic form, it is very active and has great tendency to recombine to form molecular hydrogen. This is exactly what happens in the atomic hydrogen process. When the molecular hydrogen passes through the arc, much of it is changed into the atomic state and thus absorbs considerable amount of energy. In escaping the arc stream, these atoms recombine into molecules again at the outer edge of the arc fan, and the extra energy is released as heat. This extra heat is added to the intense heat of the arc itself, produces a temperature that is somewhat higher than either the ordinary arc or the gas flame. Theoretical temperature of the atomic hydrogen flame has been found to be 7,254 degrees Fahrenheit. However, heat absorption due to the formation of atomic hydrogen, it says here, reduces this to 5,340 degrees. But it talks about the what you're talking about as far as recombining.
Yeah.
So all these books are making mistakes, I guess.
The thing that's interesting is that liquid hydrogen is 99% atomic hydrogen. Or, no, there's ortho and parahydrogen. I can't remember which is which, but one of those states of hydrogen has a lot more energy. Just because they're not pointed opposite directions, the atoms are pointed the same direction. And I thought, well, this is interesting. This is another free energy process hiding in there between ortho and monohydrogen. Ortho and parahydrogen. Because it takes less energy to create parahydrogen than you get back when they convert.
How about that?
And that's just another one of those little free energy processes. The same thing happens, when you compress it and liquefy it, it takes less energy to vaporize it again than it took to compress it.
Really?
In other words, when you can vaporize it easier than you compress it. So you get a gain in energy, just like that. And you can do the same thing with liquid air.
It happens quite a few times in nature, and yet we're taught to ignore that again. I don't see how people...
See, I don't think it's
see how science people can explain this stuff away all the time.
I just think that these elements are absorbing energy from cosmic sources when they're in a state of change. And because Tesla's theory of radioactivity is that the radioactive elements are not producing the radiation. They actually are being produced by the element reacting with zero-point radiation, what he called the primary solar rays or starlight, a very high-frequency form of radiation that's produced in stars. And he called this the primary solar rays, and I call it the zero-point radiation because this matches the definition today. And this radiation is ubiquitous. It comes from all directions. It's so high frequency it doesn't react with most matter at all. It passes right through everything. But I believe that certain elements, when they react and change, when they're in a change of state, or let's say they're in an act of transmutation, such as in K-capture, that they react with this and produce a radioactive effect. Because I don't think they've ever proven that mass loses weight through radiation. That's all strictly mathematical predictions. Yeah.
Oh.
According to E equals mc squared, if something sits there and puts out this high energy radiation, it's supposed to eventually convert all the mass, as long as it's producing radiation, into pure, what they call pure energy. And that's the biggest joke I've ever seen in my life. There's no such thing as pure energy. What would be pure energy?